In this final part of taking a look at the VR multiplayer project template, we take a look at how we can use some of the components to build our own minigame. We'll take a look at how we can use the minigame manager class to power our experience, and how we can create our own custom script to enable us to control the functionality of our game. As we've seen in the sample scene, it comprises 3 minigames: climbing, whack-a-mole and slingshot. These minigames can be found under gameplay and then minigames. If we take a look at these minigames, despite them being very different in gameplay, there are some common elements between them. One of these common components is the minigame manager script. The minigame manager class is the backbone of game state management in the VR multiplayer template. It synchronizes the game state across all players on the network and handles transitions between pre-game, in-game and post-game phases. During the pre-game phase, players can join and ready up, and once everyone is ready, the minigame manager triggers the in-game state, starting the countdown timer and enabling player interactions. At the end of the game, the post-game state displays the results, updates the best record, and resets the game for another round. The minigame manager also handles player teleportation, ensuring everyone is in the right location based on the current state. By connecting the minigame manager to your custom minigame logic through the minigame base class, you can focus on implementing unique mechanics while the core game state and synchronization are managed for you. This makes creating network minigames efficient and straightforward. And this is something we can leverage in the creation of our very own minigame. If we extend each of the minigames in the hierarchy, we can see the similarities between the components. Each one has a canvas, a leave teleport spot, a game platform, barriers, and then the core components of the actual minigame itself. And we can use these prefabs as the foundation of constructing our very own minigame. By selecting it in the hierarchy and then clicking on select, we can see where the prefabs for these minigames are stored, and then we can create a brand new scene. In this new scene, as we did before in the previous video, we'll go ahead and add the required components. So we'll start off and we'll add the XRI network game manager. Drag and drop that into the hierarchy. And we'll also add the network manager VR multiplayer. And then lastly, the XR origin hands. And we'll use the MP template variant. Drag and drop that into the hierarchy. Also go ahead and create a floor. We'll put plane in the scene. We'll call it ground and put it at 0, 0, 0. And then we can scale it up. Now back in the sample scene, we also have this UI element, which contains the world space canvas and the spatial panel UI and the event system as well. We're going to use this element because it contains the offline menu UI, which is also up ready to go for us to customize our avatar and also create or join a room. So I'm going to make a prefab of this component, and I'm going to drop it into my prefabs folder and then move back to my scene that I'm working on. I'm going to drop the UI prefab I've just created into this new scene. If I click on it to extend it, go ahead and turn off the spatial panel UI. Under the world space canvas, we don't need the object dispenser for this, or the music player, message board UI, room info UI, or the tutorial. But we do need the offline menu UI because this is what contains the player appearance and UI for the lobby. I really don't need this door object, so I can go ahead and turn it off. And then on the parent object for the UI, we have the connection toggler script, which listens for connections and activates things whether we're online or offline. I don't want my door object to become available, so I can just go ahead and turn off this component for the time being. This setup is now enough for us to use to enable us to customize our avatar appearance and create a room and then have other people join that space. Now that the UI prefab is in the scene, we'll notice that the player list initializer has a couple of empty slots, which we can replace easily. And the player list initializer ensures that the player list UIs are ready at game start. Each player list UI dynamically displays connected players, it updates their status, and highlights voice activity in real time. And we can find these missing player UI components under the XR origin hands, canvas body lock UI, room panels, and under the room options panel, you'll see we have a player list UI here. Go and drag that into the slot, and then we'll do that for the same for the room options panel client. Drag the player list UI into there. And next we'll take a look at introducing one of the minigame prefabs and customizing it to create our very own game. And now I'm going to start taking a look at actually creating a minigame. With the template, there is some assets we can use to speed this process up for us by going to the VR MP assets, minigames, and then the minigame prefabs. And you'll notice here we have the prefab minigame world space variant. We go ahead and drag and drop that into the scene. If I move this out, we can take a look at what this comprises. So we have the minigame manager script already assigned to this with all the components that allow the minigame to function and allow us to play with other people. If we open up the minigame world space variant, we can see it has the canvas, the leave teleport spot, the game platform, and the barriers. In order to leverage this, we need to add our own artwork for whatever our game is, and a custom script that communicates with the minigame manager script. As we can see, it's looking for a current minigame, which inherits from the minigame base. If we drop in another minigame that's already been made, and we extend it down, you can see it has exactly the same components, apart from it's got this slingshot minigame assigned to it, which contains all of the game objects required for that game. And on the parent, we have our current minigame component assigned, which is at the bottom here. We see the minigame slingshot script. So for now, I'm just going to turn that off a second, and let's take a look at actually adding in the artwork for our game, so we can see that this start to take shape. And then we'll look at creating our custom scripts that contain the logic and the functionality to connect to the minigame manager. The next stage is to start adding our artwork for our minigame, and our artwork comprises of a spawner where the ball sits into, and also a target in which the player can shoot at. We have 4 different game areas. So in our minigame, we're going to go ahead and we're going to create an empty object, and we're going to call this basketball minigame items. And we're going to duplicate this 3 times for each one of our areas. I have some artwork already made. I have a hoop, which if I drop into the scene, that shows the backboard in which the ball might hit and bounce into the hoop, and also the hoop itself as well, which is just a simple 3D mesh with some colliders around. You can see we've got the hoop and the board, and then we have our separate collision objects. I'll go ahead and drop this into my basketball minigame. So when the player teleports here, this will be where they're shooting the ball. Okay, and then we want to add a hoop for each one of these player areas. So we'll duplicate this and move it into our next player area, and same again until all 4 locations have a target. The last piece of artwork required is actually the location in which the ball spawns into, which is called the ball spawner. I drop this in to the hierarchy again. I can move it down into position and then place it next to the player location. So the same as before with the targets, we'll go ahead and put this inside the minigame items, and we'll duplicate it and make sure each area has a spawner. We also have a ball, which is a simple prefab. If I drop it into the scene here, and this is what the player is going to be able to grab, and it's going to be placed in each one of the player's ball spawner locations. And the ball is made up of just a sphere mesh filter and a mesh renderer and a sphere collider. It also contains a rigid body as well. And additionally, it's using the XR grab interactable component. And we also have a network object, client network transform, and a network physics interactable component. Each one of the players will receive a ball that will sit inside the ball area. And then when they pick it up and they throw it, they'll either score or miss, and then the ball will come straight back to the ball location. We'll be writing a script later on that controls the ball, that enables us to reset its position. For now, we'll go ahead and put a ball inside each of the player locations. For now, that's all of our artwork set up. In the next section, we'll go ahead and take a look at creating our minigame basketball class. In this section, we'll now go ahead and take a look at creating our script that communicates with the minigame manager. Our script is going to contain any features that are specific for our particular minigame. In my scripts folder, I have a basketball minigame folder, in which I can now create a new mono behavior script and then call this minigame basketball. And I'll double click it to open up in Visual Studio. First thing I'm going to do here is remove the start and the update methods. And instead of inheriting from mono behavior, our class is going to inherit from the minigame base class. Initially, we're going to get an error here. This is because we need to use a namespace, and that will be the XR multiplayer and then minigames. The entire minigame system is in its own folder within the template and uses its own namespace, so it can easily be removed if it's not required in your project. So if I go ahead and save it and we jump back to the editor, we can go and assign our minigame basketball class to our minigame world space variant. You see it's put it here. And because we've inherited from the minigame base class, it's given us access to some variables such as game name. We can go ahead and type basketball, and the game type, which is going to be score. You have time or score. The game length in seconds, currently sitting at 90, and any game interactables that are going to be used by our minigame. The only interactables we've got are our balls here, and we have 4 of those, so I can create an array of 4 of those, and you'll see it's looking for the XR base interactable. So we'll go ahead and drag and drop our ball into each one of those. This game interactables array just gives us a group that's related to interactables, giving us a centralized way to manage and reference all interactable elements in the minigame, and will also help us simplify cleanup. At the end of the game, we can iterate through the array to reset or destroy all interactables to prepare for the next round if we wanted to. We can now connect this to our minigame manager by selecting the minigame basketball script, dragging up to the top where we've got our minigame manager, and entering it into our current minigame variable slot. Now moving back to the minigame basketball class, because we've inherited from the minigame base class, we can override certain methods. For instance, by typing public override, and then by pressing space, we're going to get a list of the methods in the base class that can be overridden. For instance, we have a method called finish game, which gets called when the game ends. We have a method called setup game before the game starts, and start game as well. By overriding these methods, we can add our own custom functionality to our minigame that take place when these methods are called. So for instance, when I start the game, I may want to reset the current player score. Alternatively, if there's anything I wanted to happen when the game finished, I'd type public override finish game, and then I could add my functionality below. And also in our minigame basketball class, a method that we'll look at later will be to send the player score. So put a comment in here for later on for creating a method for the player score. Now we have our minigame basketball class set up, we can focus on the functionality of the basketball that the player picks up so that when they release it, either they've thrown it or they've dropped it, and after a short period of time it's reset back into the basket location. Let's take a look at creating the basketball controller, which is going to allow us to reset the position of the basketball once it's been thrown. In my script folder, I'm going to go ahead and create a new model behavior script. I'm going to call this basketball controller. And then each one of the basketballs in the scene will require this component. So I'll go ahead and add that component to each ball. And then we'll double click it to open it up in Visual Studio. As before, we'll remove the start and the update methods. We won't be requiring those. We will need a couple of variables. The first one is going to be private vector free origin position. So we're going to store the position of the basketball so that we know where to reset it back to. We also need the rigid body of the basketball. And then using the awake method, we can set the origin position, and that'll be equal to this transform position. And we'll also cache the rigid body by getting this transforms rigid body component. So when the player releases the ball, it's either going to be thrown or it's going to be dropped by accident. Then we're going to need to move it back into the basket so they know where to collect it from for when they're ready to throw again. So I'm going to create a new method called move ball, and I want to set my rigid body's kinematic value to true. So we're going to turn it kinematic. Then we're going to move it. We're going to put it back at the origin. Now move ball at the moment is private. I actually want to make this public because access to this method is going to be required outside of this class. So there's a couple of instances in which case the ball might fall. It might fall by being thrown, or it may fall by being dropped. If the ball is dropped, it might just land at the feet of the player, in which case bend down and pick it up again. But if they lose it for any reason, we're going to need the functionality to reset it after a certain amount of time. So we'll create another method here, which is public, and we'll call this delay move. And then we can use invoke and then name of, and then our move ball method, and then give it a time in which to invoke it. Then if once our player has either taken a shot or they've accidentally dropped the ball, after 3 seconds, the move ball method is going to be called, which resets the ball back to the basket position. So moving back to our ball, we can leverage the power of the XR grab interactables events, primarily the select exit event, which is when the object has been released. If we drop in our ball, when the ball's released, we can access the basketball controller and go to delay move. And after 3 seconds, this is going to be reset back to its position. Now, by default, we don't want our ball to move around until the player has grabbed it. So we're going to make sure its kinematic is set to true. And then when they've picked it up, which will be our select entered on our ball, we can turn the rigid body is kinematic value to false, so that it will move when the player has thrown it. And we'll do this for each ball. Now that's our ball set up. In the next section, let's go and have a look at actually creating the targets that go inside the hoops. In this section, we're going to start looking at our target. And the target is the area which the player is going to be scoring. And in this mini game, that is our hoop areas. And we have 4 of these, 1 for each player. Our hoop is set up with the artwork, hoop and board, the collision area, and we also have this object, which is the target area. This was just a cube that's been placed in the center of the hoop. So as the ball passes through it, it communicates with the basketball minigame manager to increment the player score. This collider is marked as a trigger. So on this component, which each 4 locations have, we're going to go and add a new class called basketball target. We're going to go ahead and create mono behavior script, and we'll call this basketball target area. We'll then go ahead and add this new class to our target area. And we'll do this for each one of our hoops target areas. And once that's all assigned, we'll double click it to open it in our editor. To begin with, we won't be requiring start and update methods. We'll remove those. We'll be using a namespace for this one, and that's our XR multiplayer minigames. And we're going to need a reference to our basketball minigame manager. So I'll go ahead and type minigame basketball and basketball manager. We'll assign this in the inspector, so we'll go ahead and make this public. When the ball passes through the collider, which is marked as a trigger, that fires off the onTriggerEnter method. So we'll use that onTriggerEnter method and test to see what's passed through that collider. So we need to know if it's the ball or not. So we'll do other.gameObject.compareTag and see if it's equal to our ball tag that we gave it earlier. Now, if it is, we need to access the minigame manager and increment the player score. We haven't done that method yet. So for now, I'm just going to put a comment in here that says increment player score. I'm going to go ahead and save. Let's go back to our scene and let's just assign the basketball manager, which is our minigame basketball class for each area. So grab my target area, drag in my minigame world space variant, which contains a component from minigame manager, and I'll do that for each position. Now let's extend the functionality of my minigame basketball class to handle the score. First of all, we'll create a method, and this will be public, and we'll call it local player hit target. We'll pass it a parameter of type int, which is going to be the target points. We need to wrap scoring in a little bit of logic. We only want the player to be able to score if the game is currently active. And we can use some of the minigame manager's functionality to test this. So we can say m_minigame manager.current network game state. And we can have a look to see what state the game's in. And we'll use our minigame manager.game state. And we'll have a look to see whether we are in game. If we are currently in game, then we need to increment our player score and we need to submit it to the server. At the moment, we don't have any way of storing the current player score. So at the top of the class, we'll create an int and we'll call this current player score. I want to initially set it to 0. So if we hit our target, we've scored some points. We can now say that our current player score is going to be incremented by the value of target points. So if we're on 0 points at the moment, they shoot a hoop. We get some points for that. That gets past this method. Let's say 10 points. And the current player score will be 10. And if they hit it again, it'll be 20, 30, etc. And then lastly, to finish off this method, we need to submit the score to the server. So we can use the m_ again to get our inherited variables. And we want to use the minigame manager to submit score server RPC. So we will need to pass the current player score along with the player who has scored it. So we can say XRI network player, and it's going to be the local player and the owner client ID, and then semicolon to finish that off. In order to complete this scoring functionality, we need to reset the player score. So if they finish the game and they want to try again, once they come back into the mini game, the current player score will still be equal to however it was left when the game finished, because we're not resetting it anywhere. So earlier on in the video, when we were looking at what methods we could override, we found that we could override the start game method. And here's going to be a great place to reset the score. So every game, once it starts off fresh, we'll reset our score and make sure it's 0. And we go ahead and save. So that's our method for controlling the player score. We just need to now connect this to our targets. So back in our basketball target area script where we have the increment player score, we can now access our basketball manager, which is our minigame basketball class. And we can access the local player hit target. Player has scored, and we'll say they can get 10 points for that hoop. This could be a variable that we could then assign in the inspector if we wanted to, but for the sake of the tutorial, we'll just pass the value of 10. So now when the player shoots, they score, the onTriggerEnter method is called. We check to make sure that it's actually a ball that's gone through the hoop. If it is, then we access our basketball minigame manager and its local player hit target, and we store the score and submit it to the server. This is now ready for a local test to make sure the functionality of the ball resetting is working and that the score is being calculated. So we'll go ahead, enter play mode, and test out these features. Here we are inside our VR environment. Just going to go ahead and confirm my details and quick join the public room and navigate over to my basketball minigame. Go ahead and join. It's put me in the right position where I can select where I want to be within the minigame itself. Select this one on the left, get the game starting countdown, and then we're now actively in the game. I can pick up my ball and I can drop it, and let's see if it resets to its position back to the basket, which is good, so I can never lose the ball. And I can also pick it up and chuck it as well and try and score some hoops. And then once it's gone through the hoop, it gets spawned back after that time period, and we can just keep going, have a look at our time that we've got left in the game, which is 60 seconds, and see how much you can score. So our next little step is just to make sure it works in multiplayer play mode, testing out some of the network features within a multiplayer environment. Now when we enter multiplayer play mode, one of my players is a spectator watching the minigame take place, and I'm using another player that's currently taking part in the minigame, is able to pick up the ball and throw it, and the observer can see all that taking place. So in this video, we've seen how we can take some of the features and components of the VR multiplayer project template to very quickly establish our very own little minigame that's quick and easy to set up and fun and engaging for the players. This project uses features of the XR Interaction Toolkit, and if you'd like more information, there is a free ebook available which breaks down a lot of the classes and components used in the XR Interaction Toolkit. Additionally, there is also a mixed reality multiplayer project template which extends the multiplayer experience into shared mixed reality environments. This template provides everything you need to get started. It includes cross-platform networking, synchronized objects, and player interaction systems, allowing users to seamlessly interact in the same virtual or physical space. The VR multiplayer project template can be used to very quickly build dynamic synchronized minigames for virtual reality. With its streamlined setup and robust network features, building immersive multiplayer experiences has never been easier. Thanks for watching, and don't forget to experiment, customize, and make it your own.